Okay, so to get the Manova for repeated measures, first you'll want to go to the top of the screen and click Analyze. Go to General Linear Model, Repeated Measures. Click on that. So this is going to have two factors. The first factor we're going to call tests. It has 4 levels. Add that, and that's going to represent each of the 4 tests: SHS, SWLS, PA, and NA. And the next factor, don't worry about the measure name, the next factor we're going to call pre-post. And that's going to have 2 levels to it. And that's going to represent pre-testing and post-testing. So add that. And let's go to define. So click there. Okay, so here we have test 1, level 1. Okay. We'll go to the bottom here and hit each of those over. And so SHS pretest is 1-1. SHS post-test is test 1 time 2. SWLS is test 2 time 1 for the pretest, and SWLS post-test is test 2 time 2. PA pretest is test 3 time 1. PA post-test, test 3 time 2. NA pretest, test 4 time 1. Total NA, test 4 time 2. And then the between subjects factor, which just separates our cases into groups. That's groups. So go to model, leave it at full factorial, and just click on continue. Skip over contrasts and plots, don't worry about that. Post hoc, we'll want to know the differences between our groups if there are any, so click that over and go Bonferroni. Okay, and then go to, don't worry about save, go to options. Don't worry about these estimated marginal means, just leave those blank. We want descriptive statistics and homogeneity tests to make sure we don't violate assumptions of normality. Click on continue and then click OK to run. Okay, here's our output. So going down, here's the within subjects like we talked about before, test 1, time 1, SHS, and then time 2, post-test, and so on down the line. The number of people there, how many were in each group, and here's the descriptive statistics broken out by pre, post, all that good stuff. Nice and neat. Don't worry about this equality of covariance matrices. Multivariate tests. Okay, this is what we talked about before. Wilks's lambda test by group. Okay, so that's the interaction there. And then we have pre-post, before and after. Pre-post by group. Tests by pre-post. Tests by pre-post by group. And this is significant, and that means that we have a 3-way interaction. Tests are important individually, each of the tests, by first and second, by group. So each of those 3 factors have a significant interaction effect, and so that means ignore all these other previous ones here because that 3-way interaction is the most powerful and is significant. Ignore the sphericity test there, tests of within subject factors. Effects. Don't really worry about those. They're all significant. It means that within subjects, they're significant. Within subjects contrasts. Don't worry about those so much. That's just kind of this model fit thing, but they won't ask about that. That's not really important here. It's a linear fit. Don't worry about equality of variances. This just tells us that our variances are equal. That's another assumption of ANOVA. Tests of between subjects effects. This is the big one here. So group, we go across, it's significant, and that means that between groups it's significant. But like before, experimental 1 minus experimental 2 is minus 1.16. That'll round to 0.7. So that means that group 2's score is 1.17 points higher than the score from group 1. Which supports your hypothesis there. And you go on down the line, it's significantly different as well. Going down the line, it shows you the differences for each of the groups there. So that should have you covered. It's all the tests rolled up into one. It's nice and it's neat and it's very clean and all that good stuff. All right.